Hello everybody, we're going to continue talking about section 16C, stationary points. So in our last video, we saw that if we want to find local max or min values or stationary inflection points, we find critical numbers of the function. So in other words, we determine where the derivative is equal to 0 and where the derivative is undefined for all x values in the domain of f. That's our calculus backup plan. Then we use the first derivative to analyze whether f is increasing or decreasing on either side of a critical number. Okay, and so that's our sign diagram. And based on our findings, we conclude whether each critical number is a local max, a local min, or neither, which would be a stationary inflection point. Also note that if we're asked to find the greatest or least value of a function on an interval, we also have to check the value of the function at the endpoints if we're looking for the global max or min. So here we have a question: find and classify all stationary points on the function given on a particular interval, which is different from some of the examples we've done so far. So my first step is always to take the derivative, put it in factored form, set it equal to 0, and solve for x. That's my calculus backup plan. Okay, so in my derivative here, I notice that my factors, if I set them equal to 0, I have two critical numbers or turning points, one at when x is -2 and one when x is +2. Okay, now I'm going to set up my sign diagram. And this sign diagram looks a little different. I just put the f of x part underneath, and I put my test values at the top. But otherwise, it's the same idea. I draw my number line, and this time, instead of having negative infinity and positive infinity, I have endpoints at -3 and 4. So I only care about the function between when x is -3 and when x is 4. Then I'm going to put in my critical numbers or turning points at -2 and 2. And because this is a polynomial function, I know that it doesn't have any asymptotes to worry about. I'm going to evaluate the value of the derivative. So I'm going to consider, what about if I pick a value between -2 and -3? So this is my sample value, -2.5. If I plug that into my derivative, I would have a positive times a negative times a negative. And altogether, those signs would give me a positive result, which would indicate that my function is increasing. If I pick a number between -2 and 2, the best one to choose is always 0. Then I'm going to have a positive factor, and a negative factor. So together, a positive times a negative is going to give me a negative result and mean that we have a decreasing function. When my derivative is negative, it indicates decreasing function. Last, I'm going to choose a number between 2 and 4 to test. I'm going to pick 3. If I plug 3 into my derivative, I'm going to get a value that's positive, positive, and positive. When I multiply 3 positive numbers, I get a positive result. So my derivative is positive, and that indicates that my function is increasing. So far, that's the same as what we have done in the previous lesson. You can even draw some little dotted lines to kind of connect those arrows to get an idea of your shape. What's new is that we're now going to definitively say that if I went from increasing to decreasing, then -2, when x is -2, must be a local maximum. And if I've gone from decreasing function to an increasing, okay, if I've changed from decreasing to increasing, then this must be a low point. And so therefore, x equals 2 is a local minimum. Okay. And if we have to find the values, so remember my question asked me to find and classify all stationary points. That means I need not just the x value, but also the y. So I'm going to go back to my original function, not the derivative, and I'm going to plug in when f is -2, y is 13. So we have a point at -2, 13. When x is +2, y is -19. So we have another point here at 2, -19. And we're also going to check the endpoints because those could be actually higher or lower than these points. So I plug in f at -3 and f at 4 to get these values. So now I have 4 points. The highest that my function ever gets, the highest y value, is both when x is -2 and when x is 4. The lowest that my function ever gets is -19. So that's my global minimum. And this point is just a local minimum. Okay, it's low, but it's not the lowest. Thank you.